Good. So you realize that you get in the bracket y plus 2q. This bracket is also 2q plus what? Y. Do you know they are the same? Because addition and multiplication are what? Commutative. Addition and commutative. Commutative means, if you remember, if you watch real number system as we did, so let me write it here. A plus B is equal to B plus A. You remember that? It's the same. Let me use numbers for you to agree that it's the same. 2 plus 3 equal to 3 plus 2. What do you have here? 5. What do you have here? 5. So if it's addition or multiplication, the order of arrangement doesn't matter. It produces the same answer. Therefore, it's commutative. So now you pick one, letting the arranging it in alphabetical order. You get a picture. So which one comes? Y and Q. Which one comes first? It's Q. So I write the common factor. That is this and that. Common factor is what? 2Q plus Y. I'm picking the second one because that is the order that gives alphabetically. Do you understand? It gives you alphabetical order. Then what is left here? If I brought this one outside, what is left here? So I bring my bracket 2x. What is left at this side is minus. Take note. So minus what? 3p. This becomes your answer. So when you finish and those in the bracket are not the same, there's an error somewhere. You have committed a mistake. Now watch here. In the course of multiplying, we said watch here. Come to the question. The question is down here. You see that we said this is common, right? So we brought what out? We brought negative out. Now we didn't put negative in the bracket. Do you know why? If you bring negative out, it had been taken away, right? And what is outside the bracket, when multiplied by what is inside, must give you the original. So negative times positive must produce the negative here. So watch here. Negative 3p times positive y will give you negative 3y. Because negative times positive is what? Positive is negative. The answer must be negative. It must produce the original. So when you bring negative out, put positive inside. Take note. Even if you are not sure, check here. If you are very sure of the first one you have done, it's likely, if this is plus, it's likely here will be with plus. Take note. Because those in the bracket might be the same. So that is the end of this side. Method of grouping. You group it into like terms to each. Factorize each. When you finish, you see a common terms in each of the bracket. The bracket must be the same to prove that we are right. Okay. Now let's move to the next type of factorization. Okay. Good. The next type of factorization is difference of two squares. Difference of, there must be a subtraction between them, and it's two squares. So one term should be a square term. The second term must also be a square term. That is the only way it qualifies to obey this command. Let's see how it works. So looking at the first example, x squared minus y squared. This is squared. This is also squared. Therefore, we can write it this way. X plus y, x minus y. And like I said, the examiner can choose to bring the minus first and the positive second. Either of them is correct. So that is the picture. Why should we write it that way? We will prove it when we are done with it. We are going to do a lot. After that, we will prove one or two of them for you to see how it works. Even the proof, when you expand this, it gives you this. The simplification will give you this. So let me simplify this one, then we can use it as a this thing, right? So let me expand this one. I'm expanding it equal to, you see, bracket means multiplication. So if you pick the first one, you multiply by the two of them. Pick the second one, multiply by the two of them. That is what it means. So let's pick the first one. X times x gives me what? X squared. X times y, remember, it's negative. X times negative y is negative xy. Negative and positive meet. You choose the negative. Then we are done with that. We are using to pick the two. Now y. Y times x gives you yx, which is the same as xy. Multiplication is commutative, so the arrangement is as matter. We just want orderly presentation. Y times negative y will give you negative y squared. Y times y squared. Watch. This is negative xy. That is positive xy. They cancel each other to become 0. Therefore, x squared. Then this one is what? Minus y squared. That is how it happens. So there's a proof. So whenever you see difference of two squares in this picture, remove the square. First one plus, second one minus, or minus and plus. You are done. That's the answer. So take note. It's not anything complex. I'm proving to you. So it's not formula anymore, isn't it? Beautiful. Let's see more examples. Let's see more examples over here. 4a squared minus 9b squared. Like I said, both terms must be square terms. Now, there's a minus. So difference of two squared. There's a minus. That's one clue. 2. The variables are square squared, telling us we are getting closer. But look at the numbers, right? What square will give me 4 is 2. So 2 squared, a squared. Minus what square will give me 9? That's 3. So 3 squared, b squared. The moment I get square terms, I have every liberty to write it that way. So now my answer is equal to 2a plus 3b. Then the same 2a, then I put minus this time around. So it's just removing the squares, putting it that way. When you expand the same way, so you can choose to expand this, you end up getting the original. Are you okay with that? So simple, so simple. So it's good to know square numbers. But then let's do last one. What's the square number of this? What square will give you this? It's 12. So you can use it. So 12 squared p squared, right? And this what square will give you this? So minus is 5. 5 squared q squared. Therefore, I can write what? 12p plus 5q. That's one bracket. Then the same thing. 12p this time around minus 5q. Another bracket. I am done. Simple. So that is what you have to do. Now, if you have a work like this, look at this type. 1 minus 225w squared. Now, the 225, the minus is giving a clue. 225 is a square number. W is the real square is a square number. It's telling you that this one is what? A square. 1 squared is 1. So it's an identity you must know. So anytime you have 1 square, it's so simple. Just put, or you have 1, put a square on top. If you suspect that the work must be difference of 2 square. Okay. Now, how do you know a number is a square number? Put it in calculator. Square root of the number. So square root of 225. You get what? 15. So now I get 1 squared minus 15 squared w squared. For that matter, I can write what? 1 plus 15w. That's one bracket. Then 1 minus 15w. That is my answer. So simple. Is it so simple? Now, look at this one. Let me write it here so that I can see it clearly. 45 r squared minus 20, right? So minus 20. Watch. The minus is giving a clue. R squared giving a clue. Now, look at these numbers. None of these numbers is a square number. So factorize. Use the common method to factorize. When you factorize, it's possible you see a square number. Then you continue. So let's see. What's the ACF of 45 and 20 is 5. So I get what? 5, 9, 45. So r squared minus 5, 4, 20. So that. Have you seen our square numbers? So at the end of the day, I end up getting something like this. So since you know you are going to open bracket already, you open this bracket and put them in. So 3 squared r squared minus 2 squared. Okay. So you can factorize this one inside as you have learned already. Then